Now in this case, if you look carefully, you see that, let's take the first refraction with this lens. You have 1 by u plus 1 by v is equal to 1 by f, which is the focal length of the lens. U is positive here, so 1 by 45 plus 1 by v is equal to 1 by 30. So you will get v as 90 centimeter. So this lens forms an image here at 90 centimeter. Now this lens has the object at its pole, so it will form the image at the same position. Now this object is at a distance of 9. This image becomes the object for this mirror, so this mirror will form an image here which is 90 centimeter. Now the rays of light will get reflected from the plane mirror and will strike the convex lens again. So the convex lens will see the object at a distance of 180 centimeter, because this image formed by the plane mirror is the object to the convex lens. So now let's see where the convex lens forms the image. I write 1 by u plus 1 by v is equal to 1 by f. What is u? See, to move from the object to the image, object to the lens, I am moving in this direction. The ray of light after reflection from the plane mirror also moves in this direction. So u is positive and it's equal to 1 by 180 plus 1 by v. Focal length of a convex lens is positive, so I get this. So finally I'll get 3 minus 1 by 180, or my v as 90 centimeter. That means the convex lens forms an image here when we take this as the object. Now this image is at the pole of this lens now, so the convex lens will form the image here itself. So this is my location of the final image. So the distance between the object and the final image is what? It's this distance, which is equal to 45 centimeter. So this is my answer. Okay, so that's all about the theory in this topic, that is reflection at spherical surfaces. Now we'll solve some problems in this topic. The first question is as follows. A convex lens with focal length of 15 centimeter and a concave lens of focal length 30 centimeter are coaxial 80 centimeter apart. Okay. Now it says that a point object O is 18 centimeter from the convex lens and 98 centimeter from the concave lens. Okay, so this is the information which has been given. Now the question is, find the nature and position of the image. Find the nature and position of the final image. So this is first part of my question. Now in the second part, what it says is that a thin glass slab of thickness 7 centimeter and of refractive index 1.4 is interposed between the two lenses. So a thin glass slab with d is equal to 7 centimeter and mu is equal to 1.4 centimeter, 1.4 is interposed between the two lanes. Now it asks to find the displacement of the final image in the direction of the image because of the insertion of this thin glass slab. So the question is, second part of the question is, find the displacement of the image because of this insertion of thin glass slab. Find the displacement. Okay, so now let's draw the figure so that you understand the question properly. The question, it mentioned that you have a convex lens and you have a concave lens. The focal length of the convex lens is 15. This has a focal length of 15. This has a focal length of 30. And this distance is 80 centimeter. An object is placed here such that this distance is 18 and this distance is 98. So the question is, find the position and nature of the final image, first part. And in the second part, a thin glass slab has been introduced, and so the question asks to find the displacement in the direction of the image. So that's it, this is the question. Now again, this question is a very simple question where you need to just apply the formulae for refraction at spherical surfaces, and in the second part you need to apply the concept of displacement when a glass slab is introduced in a medium. So I assume that you have cracked this question, and so I'll proceed with the solution. The solution to this question is as follows. So in the question, you had two lenses. This had a focal length of 15 and centimeter, and this had a focal length of 30 centimeter. Okay, there was some object here, and